The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
So to get started, I'd like to introduce Sean Monkman, who is the Vice President of Technology and Development at CarbonCure Technologies and has served in that capacity since 2008. He oversees the company's research and intellectual properties efforts as they develop scalable carbon utilization technologies. And so today he's going to be talking about how did North America's first Portland cement concrete end up in Halifax Harbour. So please welcome Sean Monkman.
Thank you very much, and thank you for putting this session together. I attended the committee meetings a few times wondering if you guys ever do these things, and now you're doing it, because I've been attached to this story for a couple of years, and I thought it'd be of great interest to the larger community, just didn't know how to share it, so I'm happy to be here today. The recap of the story is on the printed page, but if you'd like to still see the presentation, I'll go through it. So where is Halifax? It's on the the east coast of Canada. If you go up from Boston a couple of hours and stick to the water on your right-hand side, eventually you'll hit Halifax. It's the second largest city in Canada that's on an ocean. The first largest is Vancouver. The site of interest is called George's Island. It's the little island down in the right-hand corner. Otherwise, you're looking at downtown Halifax, so this is a piece of history just right across from downtown. And within the larger context, the area looks like that. So you can see the island there downtown, and if you imagine if you're, say, involved in the military a long time ago, and you bring your army there for whatever reason, that's got strategic importance for defending the harbor. So what they did is the military would start to build some forts and so forth there to further protect the ships they would have in harbor. You can see them in the picture there in the background. So that started going on, this picture being from about 1750, and you can see this fortification there as illustrated as kind of like a wooden fence or something. So at that time, very simple. In 1794, Prince Edward, who became, if you know him as the Duke of Kent, same guy, came to Halifax and started commanding the forces. And what he decides is that this island should have a better structure on it. So he says, let's build this star-shaped fort on this island, and he calls it Fort Charlotte after his mother. So what happens, let's skip ahead 60 years. What happens is the military starts to develop higher capacity, heavier weaponry. And they have developed something called rifle muzzle-loaded artillery. An example, that's not Halifax, is shown there. What that means is rifled, if anyone's familiar with firearms, you've got helix grooves on the inside of the barrel, which puts a spin on whatever's shot out of it. Muzzle loading, when you think about, ramming a cannonball down the front of a cannon, that's kind of the move they made at that time. And what they're doing is they're upgrading their cannons. They're bigger, and now they're shooting 250-pound projectiles out into the ships that may be attacking them. In practical terms, what that meant for them is that on the left, this is Halifax Harbour again. George's Island is highlighted in red. On the left, you see the smooth bore cannons, and then the switch to the rifled ordnance on the right-hand side. So basically what that allowed them to do is increase the range of their cannons by 33%. And if you look closely, all the cannons in Halifax suddenly got more range, and now they could cover the whole harbor with cannon fire if need be. So this is an example of a cannon that's still in the Halifax area at one of these structures. But there's actually still one that exists, and they still fire it. If you go down to South Africa, according to the history, this cannon actually was in Halifax at one time, and it moved around a little bit. And when you fired it, it makes a mighty boom, if you can well imagine. So what does this have to do with concrete? Well, let's just go back a bit from the 1860s and what were they thinking about concrete at the time? Portland cement had been developed in 1824. If we look at the Aspidin patent, this guy, Major Charles Paisley, he was the overseer of the engineers through the Royal Military Academy in Woolwich for the British military. And he was interested in the types of limes, mortars, and cements that were available at the time, and he did a bunch of work. Now, what he found eventually over the course of his work is that he couldn't make good concrete out of the materials he was working with, so he recommended to the Royal Engineers who were building fortifications for the British military, don't bother with concrete. What he found is when you put sand into it, it got weaker. So his advice kind of put the kibosh on concrete development. Good, yes. Wow, jumped way ahead. But by the 1850s, Portland cement, having had been developed, wasn't being used for concrete really, but it was showing up a lot in masonry applications. And people were starting to believe in it. And what you see around this time is there's a new guy in charge at this lab by the name of Captain Henry Scott. And if you're familiar with binder history, Scott Cement, that's the Scott. He does his own research into limes and cements. And he actually says that Paisley's conclusion about cement was needed an update. He had tried Portland cement and found that you could make a perfectly acceptable concrete out of this, and it didn't get weaker when you put sand into it. And he blamed the earlier results on the type of cement that was being used by the earlier researcher. So what happens, he and his partner start to tell the other engineers, oh, you should consider this in some of the things you're making, like concrete. And so they end up publishing some of this work within the context that masonry, being one of the preferred methods for construction at the time, happened to be expensive and slow. And if you're in the military, you have to acquire skilled labor. But if you can use concrete instead of stone, you can use it in certain applications. They recommended casemates, magazines, and revetments. These are parts of forts at the time. And if you do so, you're going to save time. It's faster than masonry. You're going to save money. They think it's cheaper than masonry. And certainly, you don't need the skilled labor to place concrete that you would to masonry. So they actually start telling their colleagues, you should look into this. And so they're doing lectures there in Woolwich, and they're publishing papers. An example is shown on the right. This is one of the journals from the Royal Engineers. This is actually issue number 10. They published their work in volume 11, so I couldn't actually find a copy of the original work. But this is just the way information was exchanged at the time. So what does this have to do with Halifax? Well, around that time when this work was being publicized in the Royal Military Academy, the fort again needed a little bit more attention because of these cannons that were coming in. They had a recent bad experience with some lime-based concrete that meant they had to replace some cannon footings already. And they already had this lack of skilled personnel to do masonry. So they have these two things working against them for the materials they're already using and familiar with. They see what's been done at the Royal Military Academy and say, hey, this sounds really interesting. So they actually order some cement, comes over in barrels of 4 bushels apiece, and they start to put it into practice. And this is going back to a recount of the work they did with this, goes back to a letter that was written by one of the commanding Royal Engineer in February 1866. He's reporting about his work with the concrete in Halifax to his superiors. And this is actually an incredibly fascinating document that's hard to read because of his handwriting. So I'll give you a couple of highlights about what he put in there. So I selected a font to try and capture the spirit of his handwriting, but he introduced The previous one is the letter. This is one of the three things that were in the letter, called a memorandum on the use of cement concrete at Halifax, Nova Scotia during the years 1863 to 1864 in Fort Charlotte. So one of the things he mentions is a question of labor, tough to read. What he says, a gang would be divided somewhat as follows. So how do you make concrete? He says, 4 men would be there for mixing, 2 for wheeling the concrete around, 2 for leveling and ramming. One of them is a sapper. This is a role in the British engineers, Royal Engineers. One is supplying water, and then 3 measuring and preparing materials for the next batch. So he said you could make concrete with gangs of 2 to 15 people, this being an example of a 13 or 14-man gang. Several examples of mixed proportioning are provided if you're interested to see, try and replicate the concrete. He says 1 cubic yard of concrete took 16 bushels of broken stone in 2 different sizes, and there's lots of information in this letter about where they got the stone and the men they employed to crush it up. 5 bushels of fine shingle, not sure what that is, I guess it's a kind of stone. 7 bushels of sand, 3.5 bushels of cement, and about 8.5, making about 8.5 bushels of mortar. And in this case, they're making some comment, or they recapped a comment about a lot of cement was used because the cement was not fresh. They actually, in the letter, talked about storing the cement over the winter in these barrels and how it wasn't as good after the winter. Okay? So this is within the letter talking about how much the concrete cost. Now, what the military academy was saying is you're going to save money by doing this. So they took good records on how much money they were spending to make this concrete. So it's very difficult to read, but the cost per yard they come up with for materials and labor, the labor being military men, was 16 shillings and 10 pence, which is 382 pounds of today's money for a cubic yard of concrete. So Fort Charlotte today looks something like this. Well, it looks like that, or at least it did when whoever took his drone over there and took a picture. So you can see downtown Halifax in the background on the right-hand side. And you can see the fort, which is kind of situated on top of, perched on top of the island. The fort itself is a protected National Historic Site. It's not exactly open to the public, like people can't just go to the island and poke around. And it's not really prepared for visitors, but nonetheless, we were introduced to this idea that there was some very old concrete there by a historian who was associated with the Parks Department in Atlantic Canada. And we asked the Parks Department if they would support a project for us to go actually take some course. And they said yes. So this was back in 2017. Well, in 2017, we made a site visit. So based upon the letter, they described that at Fort Charlotte, there were 4 places where they used this concrete. And I've never built a fort before, so some of these terms were a bit mysterious to me, but you're looking at gun foundations, so I guess find the cannon and look down. The escarpment walls, so that's a protective wall around the outside of the fort. They were saying in place of brick arches and galleries, so it's, okay, a brick arch, now we're looking for concrete arch. I don't know what a gallery specifically was, but I can find an archway. And then the expense magazines. So we went to the site, poked around for about 2 hours trying to rectify the written description of where the concrete was used and what we were actually able to see in the site like 160 years later or whatever. So we went into 2 different places. There's one door at the bottom and another door kind of if you follow the path up around the corner, and you get under the hill into the fort structure itself. So after looking around for 90 minutes and couldn't find any magazines and couldn't find any gun placements and whatever the other thing was, we're kind of mystified. And we're just, okay, well, we got these brick arched galleries, whatever that means. Okay, well, okay, here's some brick arches, good, okay. So we have obviously brick lining the ceiling of what seems to be a hallway to me. I don't call them galleries myself, but it's a hallway connecting one room. And we turn the corner and we see, whoa, we found it, okay? This was the concrete that's adhering to the written description of where they used it. It's on the ceiling in a location that has replaced brick. And so we thought, okay, this is really interesting. And if you look up closely, you can actually see the lines of the formwork of when they cast the concrete. So that was done last summer. And it took a long time to actually organize a return trip to actually do the coring. If you read the little abstract, it's on your seat. I don't mention doing any coring, and I'd given the abstract 6 months ago. So we did the coring last month. So we returned back to the site, again with the support of Parks Canada, and they took our word for it that we could cut a few holes in their structure and patch them up fine, and it would still be acceptable. Thankfully, they said yes. So we went through 2 different parts. Back to where I was saying, there was 2 locations here you could enter the structure. We went into one location and took 2 cores, and went into another location and took 2 more cores. So our project plans, now we've got 4 cores. We're going to do some material characterization. As part of this project, we had a couple of principal investigators working with us. So we'll be handing the concrete off to Doug Hooton at the University of Toronto and Mike Thomas at UNB. And they'll tell us what we can learn about looking at this concrete all these years later. And this is a good-looking core. The first one we took out had massive voids in it, very poor consolidation. And from what I understand, with the way concrete was made at the time, you would throw it onto the form, and then if you go back to the crew, there were job roles called rammers. So then you would ram it down, you jump on it or whatever, you try and pack it into place. So it was not very, I guess, super plasticizers weren't invented yet. And when we were coring that one, the voids, you have a water-cooled coring machine, and there's no more water coming out as you're coring. Usually water dribbles down because water was going into the wall through a hole, and who knows where it went. It was like a mystery, so we pull out a really lousy-looking core. But the other 3 looked pretty good. So my acknowledgements go, of course, to Parks Canada for letting us do this. You come up to a project to someone who's preserving something like this and say, I want to punch some holes in it. They could say no. They said yes. Further, I'd also say this work is in memory of Bill Neftal, who's the historian. He passed away earlier this year. And I'll leave you with a quote from someone who was recapping the work for his superiors there. He said, for economy, dispatch, and military labor, the advantage of concrete is undoubted. So all you masonry guys can just go, concrete is here. Thank you.
So once these cores were taken, what were the test results?
We haven't actually handed them off yet, so I'll talk to Mike and Doug this week, and maybe at a future history of concrete session we'd have some results to share. But ultimately, I think with a project like this, we'll try and find a place to publish the work, if not talk about it here.
Okay, are they going to do a petrographic analysis?
Yes.
Good.
Thanks, Sean.
Thank you.